Okay. We are on 0-11, simple probability and odds. Turn your book to P33. This is where you should be. Two definitions in which we need to talk about before we go ahead into the notes and practice. It says define probability. The book says the probability of an event is the ratio of the number of favorable outcomes for the event to the total number of possible outcomes. Well, a ratio is a fraction, and then it says favorable outcomes. Well, favorable outcomes is actually what we want to happen. So I like to simplify those words. And then it says over the total possible outcomes. So then it's over the total. So I like to simplify probability and say that it is want over total. The sample space is the list of all possible outcomes. It's a list of all possible outcomes. So here we go. Notes. If they want to know the probability of an event or another event, not even event, we must add both probabilities together. If they want to know the probability not of an event, then we add all the other possibilities. That'll make sense once we are looking at some examples. So on example 1, just like in your book, a die is rolled, so a die is a dice, is rolled. Find each probability. So I want to go ahead and find rolling a 1 or 5. So 1 or 5. So or means to add, so I need to add the possibilities. Okay? Well, how many ones are on a die? Well, there's only one. How many 5s are on a die? Well, there's only one. So I want 1 or 5, which is 2 possibilities. And then how many sides are there on a die? 1, 2, 3, 4, 5, 6. There are 6. So we have 2 over 6. I can reduce this, divide by 2, and we get 1 over 3. That is my probability of rolling a 1 or a 5. Let's go ahead with letter B. Rolling an even number. So we already know that there's 6 possibilities, so we'll put that on bottom. An even number is 2, 4, 6. So there are 3 possibilities. We can reduce this by 3, and we get 1 over 2. Let's go ahead and define complement. So the complement is actually the opposite of what we want. It's the opposite of what we want. So the complement connects with this not. So it's the other part. It's the other part. So the complement would actually be the not part. It's the not part. In my words. So if we have what we want, then we would have what we don't want. The complement is what we don't want, and if we add what we want plus what we don't want, that will always equal 1. Slightly confusing, I understand. So let's go ahead and give an example. So let's go ahead, actually not this one. let's go ahead and look at this. So rolling an even number, so what I want is there's 3 even numbers over 6. So 3 over 6 reduces to 1/2. What do I not want? Well, so the complement would be the odd numbers. So the odd numbers would be 3 over 6 again, because there's 1, 3, 5, which would reduce to 1/2. If we ever add what we want with its complement, then we will always get 1 over 1. So if I add this, I get 2 over 2, which is the same thing as 1. Example 2. A bowl contains 5 red chips, 7 blue chips, 6 yellow chips, and 10 green chips. 1 chip is randomly drawn. Find each probability. So I want blue. So this example is on P34. So I want blue. Well, how many blues do I actually have? So I got 5 red, 7 blue. Then what I need to do is find the total. So 7 is what I want, and then I have the total. So probability is always 1 over total. 5 plus 7, 12. 12 plus 6, 18. 18 plus 10 is 28. Can I reduce? Yes. That would be 1 over 4. My probability is 1 over 4. Letter B. I want red, or means to add yellow. So how many red chips are there? 5. How many yellow chips? 6. And I actually know that the total is 28. 5 plus 6 is 11, so my probability is 11 over 28. Letter C, not green. I do not want green, which means I add all the other possibilities. 5 is red, so that's not green. 7 is blue, that's not green. 6 is yellow, that's not green. And then it says 10 green. I don't want green. So now I can go ahead and add these. 5 plus 7 would be 12. 12 plus 6 is 18. So I would have 18 over 28. I can go ahead and reduce this by 2. 9 over 14, and that would be my answer. The next definition is a tree diagram. What the tree diagram, the definition, what it shows is all of the possibilities. Shows all the possibilities using columns pretty much. So let's go ahead and look at example 3. School baseball caps come in blue, yellow, or white. The caps have either the school mascot or the school's initials. Use a tree diagram to determine the number of different caps possible. So let's go ahead and think about this. So there are two things in which we're looking at. We're looking at the color of the cap, and we are also looking at the design of the cap. So these would be columns because we're going to go ahead and we're going to write underneath our columns. What colors do we have? Blue, yellow, white. They can either have a mascot or they could have the school's initials. So right now we are creating a tree diagram. So let's go ahead and look at this. All the possibilities I could have is I could have blue and a mascot, or I could have blue with its initials. I could have yellow with a mascot, or I could have yellow with initials. I could have white with a mascot, or white with initials. So what are my possibilities? How many do I have? I actually have 1, 2, 3, 4, 5, 6 possibilities. And a shortcut for this, if we ever have more than one outcome or possibility, we can actually multiply what we see. How many colors do I have? 3. How many designs do I have? 2. This would be 6. What I just showed you is actually the definition of fundamental counting principle. So what we actually do is we multiply our different how do I want to say that? We would multiply our different options is the best way I could say that. So we would multiply our different options. And that's exactly what we just did. So let's go ahead and look at example 4. Use the fundamental counting principle. An ice cream shop offers 1, 2, or 3 scoops of ice cream from among 12 different flavors. The ice cream can be served in a wafer cone, a sugar cone, or in a cup. Use the fundamental counting principle to determine the number of choices. So the first thing that we see is we have scoops. I get to choose out of 3 different types of scoops. Then I get to choose my flavor. Well, there are 12 different flavors. Then I can either get that in a wafer cone, sugar cone, or in a cup. So I can get this served in 3 different ways. So instead of trying to make a tree diagram, I can do the shortcut and I can go ahead and multiply this. So I would have 12 times 3, 6, 3. Multiply that by 3, 18, 9, 10. I would have 108 different possibilities. Makes our job way easier. Let's go ahead and look at letter B. Jimmy needs to make a 3-digit password for his logon name on a website. The password can include any digit from 0 to 9, but the digits may not repeat. How many possible 3-digit passwords are there? Well, here's what this would look like. He needs 3-digit passcode. So we would have the first number, we would have the second number, we would have the third number. How many possible numbers can he choose from in number 1? Well, he gets to choose any 0 to 9. So if we count from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's actually 10 possibilities. Then if we cannot repeat, we cannot use one of the numbers from number 1, so now I have 9 possibilities for the second digit. Then I have 8 possibilities for the third digit. If I multiply this out, I will get 720 different possibilities.